Hello. Ah! Hello. What paper are we busy with? Oh my goodness. Okay. Welcome to. Oh. Welcome to a ramble. We are busy with the department's paper 2 of November 2022. November paper 2. November 2022 paper 2. Right. Looking at question 4 today. Let's go. In the diagram, we have the point M with coordinates 3 and -5. It is the center of the circle that has Pn as its diameter. Okay. KL is a tangent to the circle at N with those coordinates. Tangent. Right. First question. Calculate the coordinates of P. Oh my goodness. I am so sorry. What is happening? Wake up. Splashing water on my face. In my mouth, more specifically. Okay. So we know that Pn is a diameter, right? Meaning it's one nice straight line. It's not like clump, 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 clump. One straight line where M is right at the middle of that line. Right, M is the center of the circle, M is the center of the diameter. So this is the midpoint of the line segment Pn. So we can then work backwards to figure out what P is. So we know that M is the rather well named, midpoint of Pn. So therefore we know that 7 plus the x coordinate of P divided by 2 is equal to 3. And so that means that 7 plus the x coordinate of P is equal to 6, which tells us that the x coordinate of P is -1. So that's one done and dusted. And then to work out the y coordinate is pretty similar. So we have -2 plus the y coordinate of P will be equal to -5. No, it's not true. It's the average of the two, which will give us -5. So -2 plus the y coordinate of P is equal to -10. And so the y coordinate of P is -8. Huh? Uh-huh. Ooh. And so therefore, the coordinates of P are -1 and -8. Right, memo? Yes, -1 and -8. Awesome. Next up, determine the equation of the circle, this guy, the circle, in the form, I'm just laughing at how I had to point out that this is the circle. Anyway, in the form x minus a squared plus y minus b squared. Okay, so in the standard form. At this point, we know what its center is, so we know what a and b are. We just need to figure out the length of the radius. And thankfully, we have two available to us. We've got mn and mp, so I'm just going to figure out the length of mn. So r is equal to the length of mn, which we can figure out by working out the difference between the x coordinates squared plus the difference between the y coordinates squared. Very generous square root there. Okay, right, and as we know, I will not use a calculator because why would I do that? It's just it's a luxury I don't deserve. Right, so R is 5 units long, and so therefore the equation of the circle will be x minus 3 squared plus y minus minus y plus 5 squared is equal to r squared, 5 squared, which is 25. Do we agree, Memo? That we do. Awesome. Why is the diagram squished in a weird corner? Oh no, is that everywhere? Oh, okay. Anyway, determine the equation of KL, the tangent, in the standard form. Okay, right, so in order to do that, we're going to find the gradient of the diameter, because we know that the diameter and the tangent are perpendicular. So if I know the gradient of this guy, I can then work out the gradient of this guy and then sub in this point to figure out what C is. So let's do it. Minus 2 plus 5 is 3. 7 minus 3 is 4. Right, and then we know that MN is perpendicular to KL because tangent KL is perpendicular to radius MN. Okay, and so therefore the gradient of KL will be equal to the negated reciprocal of the gradient of Mn, so it will be negative 4 over 3. Okay, so then we know that equation of KL looks something like this. Y is equal to negative 4 over 3x plus some y-intercept. So to find that y-intercept, we're going to sub in the point N that lies on the line. So then we get that. Okay, and so therefore C is equal to negative 2 plus 28 over 3, which is negative 6 over 3 plus 28 over 3. Oh, this is not giving me good vibes. It's not giving me good vibes. Oh, I'm looking at the wrong line. Okay, sorry, I was worried about the y-intercept being positive because I was looking at this line. I'm thinking, this y-intercept does not look positive, but yes. Okay, so this is 22 over 3. And so in conclusion, the equation of KL is y is equal to negative 4 over 3x plus 22 over 3. We agreed, Memo? We do. Right, on to the next one. So this has been pretty textbook stuff so far. What's happening right now? Delete. Okay, right. For which values of k will y is equal to minus 4 over 3x plus k be a, I don't know how to say this word, secant. I don't even have internet connection right now. Let me see if I can find out. I'm gonna take my chances. Pronounce the word that I can't pronounce.
Secant.
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 secant. What a weird word. Anyway, what is it? It is a line that cuts the circle more than twice. Not more than twice. It cuts it twice. Okay, so tangent cuts it once, secant cuts it twice, and then random line doesn't cut it at all. I don't know if that is a special name. Anyway, so we are looking for places where the intersection between this and the circle, we will have two intersections. So I'm just going to remind myself here, the equation of the circle. We said, I'm just going to copy that from where we worked that out. That's not fine. Sorry, I thought it's fine. It was not fine. Yeah, no, I left some things behind anyway. Okay, right. And so, intersection between these two. So essentially we're solving these simultaneously. So I'm going to use the method of substitution to replace this y over here with this expression for y, that is in terms of x. So we have x minus 3 squared plus negative 4 over 3x plus k plus 5 squared is equal to 25. So just to highlight again where that is coming from, we just replaced the y with this situation. Okay, and now we are going to expand. So x minus 3 x squared. Is this really what I need to do? Because this expansion is going to get so messy. So I need to rethink my life real quick. So I feel like, let's look at this visually. So we know that when k is equal to what it currently is, 22 over 3, then this is a tangent. It's cutting the circle just once. And if it moves further up from there, you know, if it keeps going up, if you just take this guy, because the gradient is the same, so really we're just taking it and moving it upwards, right? It's just going to get further and further away from the circle, so it's not going to cut the circle at all. But if we move it just a smidge lower, right? So if we just imagine we complete, well, let me do it with my ruler. Okay. Oh my god again. Ooh. Okay, right. So if we, actually this ruler is useful to keep around. So what I was saying was, if we move this graph up, right, it's just going to move away and away and away. Oh, wait, I'm changing my gradient a little bit. Okay, something like that. No, it's not quite like that. Okay, something like that. Anyway, if we just move it up, then it moves away from the circle, right? So there are no intersections anymore. But if we move it down, then it's a secant. It's a secant, right? It's intersecting with the circle twice until we have a tangent again, right? Which I suspect happens at P. It makes sense to me that it would happen at P because the gradient of MP is the same as the gradient of MN. So it makes sense that the other tangent that would have the same gradient as this guy would happen at P. Anyway, so that's where we're next going to have a tangent that has a gradient of negative 4 over 3. And if you then move this line lower than where it is at this point, it's not going to intersect with the circle anymore, right? Okay, confusing to use this ruler because it's like, what are we looking at? Are we looking at this side? Are we looking at this side? But I hope that was not too terrible to follow. Anyway, so the idea is that, yeah, it's going to be a secant for as long as the tangent, not the tangent, for as long as, oh no, okay, not, it's fine, the point was made. But so for the values of k where the line is below this point and it's above the y-intercept of this tangent, right? For as long as the line is between those two y-intercepts, so long as the y-intercept is between those two y-intercepts, then it will be a secant. Anything above it, it doesn't intersect anymore. Anything below it, it doesn't intersect anymore. So that is the approach, actually, that I think is less messy to take. So let's do that rather. When k is equal to 22 over 3, the line is a tangent to the circle. Okay. When k is greater than 22 over 3, the line doesn't intersect with the circle at all. Okay. When now we need to find, okay, this tangent. So I'm just going to, on the side here, do a random working. P, which we found to be -1 and -8, I think. Let's double check. Yes. Okay, so -8 is equal to -4 over 3 times -1 plus k. -8 is equal to +4 over 3 plus k. So k is equal to -8 minus 4 over 3, which is the same as -24 over 3 minus 4 over 3, which is -28 over 3. Okay, so tangent at P has the equation y is equal to -4 over 3x minus 28 over 3. Okay, so what does that help us with? It helps us with this little thesis we're writing. So it's actually, here we can, when k is equal to 22 over 3, or when k is equal to -28 over 3, which we have just found here, right, then the line is a tangent to the circle. So it's either this tangent or it's the tangent at P, right? When k is greater than 22 over 3, or, yeah, that's not going to fit, or k is smaller than -28 over 3, then the line doesn't intersect with the circle at all. And so therefore, when it is when k is between negative 28 over 3 and 22 over 3, the line will be a secant. Right. And we are not including the boundaries, right? Because when k is equal to either of these, then the line is a tangent. It's not a secant. It only intersects with the circle once. And that's what I believe. Let's see how the memo feels. Yep, same thinky winkies. Right. Okay. Good on us for dodging a big algebra bomb. Although for fun, you could just do the algebra bomb and see how it goes. Hee hee hee. It is a brand new morning, and the algebra side of me woke up feeling very vindictive. So yeah, I woke up with the desire to know actually, where does the algebra brick road ultimately lead? So yeah, I just woke up wanting to do the messy algebra work and see whether it's going to give us the same result as kind of our intuition that we used also gave us. I mean, I suspect it will, but with the additional benefit of having like a physical, it's a written proof, as opposed to kind of our intuition that we kind of worked our way through in words and, with the eyes. So yeah, just to then recap what the goal is, we are looking for the values of x such that such that no, okay, what am I saying? We're looking for the values of k. Oh my gosh, not x. No wonder I was getting tongue-tied. Right, so we're looking for the values of k such that the intersection between the circle and this line over here, there will be two intersections. So we know that when k is, the thing about doing this on a brand new day is that now I don't know what the values are. So when k is 22 over 3, right? Like, so when we have this line, then this line is a tangent. It's only intersecting the circle once. And we saw that when k is negative 28 over 3, I think, so this guy over here, when k is equal to that, then the line is over here and it intersects the circle once again, so it's a tangent. So we want to see where, for which values of k will the line be something like something like this, something like this, or something like that, something like that. Right. Anyway, so I have a feeling that, okay, we're going to expand this. It's going to end up being a quadratic equation because of the x squared situation that's going to come out of it. We're going to rewrite it in the standard form of a quadratic equation. We're going to use nature of roots, our nature of roots knowledge, to show that for certain values of k, or these are the values of k for which the equation has two unequal roots, i.e. these are the values of k for which this equation has two distinct solutions, and therefore the circle and the line are intersecting twice, and therefore the line is a secant. So that's where I think this is going to go. So let's get into the messy. X squared minus 3x minus 3x, and then minus 3 times minus 3. Okay, and then for this one, there is a lot of multiplication going on here, so I'm just going to split it up. Essentially, we want to, I don't even think it's going to fit on one line, so I'm just going to take control of the situation. Okay, so we're going to multiply this, not that, this, with the whole bracket. Okay, and I'm just going to copy the bracket because okay, and we're going to multiply the k with the whole bracket. Oh, okay. And then lastly, we are going to multiply the 5 with the bracket. Right, so that's all that needs to happen. And we know that that needs to be equal to 25. Okay, let's see how much I can put back onto one line. An innocent bracket was accosted. Okay, so let's go ahead and get into the multiplication games. Yay! This shelf is always so willing to just spring out, and I don't know if I have ever needed it to. Anyway, so negative times negative gives us positive 16 over 9 x squared minus 4 over 3 k x minus 20 over 3x. And then down here we have, oops, minus 4 over 3kx plus k squared plus 5k minus 20 over 3x plus 5k plus 25 is equal to 25. Okay, so we can already see that these guys are going to cancel out, right? If I minus 25 on both sides. And now it's time to gather the like terms. So x squared, and remember what I really care about is getting this equation into the standard form for a quadratic equation. So I'm going to highlight all the, so technically I'm not highlighting like terms. I'm going to highlight firstly all of the x squared terms, and that's as much as I'm getting. So I'm going to write this as 1 plus 16 over 9. I mean, I can't just add that and simplify it. So those are the x squared terms that I get. Right, next up I want the x terms. So this one too, this one, that one, this one, right? So okay, so that will be plus minus 6 minus 4 over 3k minus 20 over 3 minus 4 over 3k minus 20 over 3 times x. Okay, and then what's remaining is my constants. So I have 9 k squared plus 5 and the 5k. Okay, so that is 9 plus k squared. Hey, why is k is getting funky and funky looking? K squared plus 5k plus 5k, right, is equal to, we now just have 0 left on that side. Okay, so let's simplify what's in the brackets a bit. I'm also just gonna go ahead and add a page because we are about to run over. Okay. I'm coding in the wrong orientation. Okay. Yeah, one time I was struggling with writing because everything just feels so small. Okay, right. So 1 plus 16 over 9 is 25 over 9 x squared. And then over here we have, now we're really going to look at like terms. So these are like terms. So yeah, those are like terms, and I need a different color. I don't really feel these are darkish colors. Don't we have some light colors up in here, guys? This will do. And these are like terms. Right. So the k's give me minus 8 over 3k, and the constants give me minus 58 over 3, I think. Yeah, that feels right. Okay, and then same process down here, or sort of, maybe a bit easier to see. I'm going to replace you as well with a nice gentle color. So the constant is just u. Oh, maybe. Ooh. Right, and then the last two. All right, so we have here k squared plus 10k plus 9, right? And those are the constants. Okay, so now we have our equation in standard form, right? We have our x squared term, our x term, and then our constant. Okay, because remember at the end of the day, k is going to just be some number. Right, so some number like 22 over 3 or minus 28 over 3, as we've already seen. Okay, righties. So now we want to figure out the nature of the root. So we're going to calculate what the expression for the discriminant is. So remember that that's given by b squared minus 4ac. So my b is this guy. Ooh, more multiplying. Yum, 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 yum. Okay. Minus 4ac I'm just thinking I could possibly have avoided fractions by multiplying through here with a 9. I don't think it's too late for me to change my mind. I'm going to go right ahead and change my mind, right? So it's times through by 9. Okay, so we're going to have 25x squared, and then here we're going to have minus 8 times 3, which is that, and here we're going to have minus 58 times 3, which is minus 174. Yep. And then over here we're just timesing everything by 9 straight. And then this will remain a 0. Okay, yeah, I like that. So now the discriminant will be minus 24k minus 174 squared minus 4 times the a and the c. Okay, right, and I wonder if there is a common factor here. Let's see. So 24 is 2 to the 3 times 8. 174 is 58 times 3, which is 2 times 29 times 3. Oh, look at the confidence of saying that 24 is 2 to the 3 times 8. It's 2 to the 3 times 3. 8 times 3. So the common factor would be 6. I don't know if taking out okay, I think taking out a 6 does kind of help multiplying out. So I'm going to take out a 6. And in fact, I'm going to take out a negative 6. So that we're left with positive 4k plus, here we'll be left with a 29. And that's what we're going to square. Okay, double check. 29 times 6 is 174. Yes. Okay. Right, and then here we have 100 times this. So that's a very nice multiplication we're going to do. Okay, so we got rid of fractions just to work with very big numbers. Exciting. So this is 36 times 4k plus 29 squared. And here we have 100. Oh, could this be a difference of squares? Let's see. Let me see if I can factorize this. So this would be, well, we can, so over here we can factor out a 9 just so we can see more clearly what is going on. K squared plus 10k. Oh, I don't think it's going to be a difference of squares. So this will be 900 and this will be k plus 9 times k plus 1. Mu mu mu. So no two difference of squares. Let us multiply out, kids. So right. Well, yeah, I should have known that. No, never mind. Okay, so this will be 900 k squared minus 9,000 k minus 8,100, as the Americans would say. Okay, and here we have 36 times 16k squared, and then 4k times 29 and 4k times 29. So that's 29 times 8, which is 290 minus 58, which I think is 232. We double check. Also. Okay, 29 times 8 is 232. Yay. Okay, and what is 29 times 29? So that'll be, so I'm thinking of it in terms of 30 minus 1 times 30 minus 1. So that's 900 minus 60, which is 840, plus 1, which is 841. Do we agree, calculator? Ooh. Yes. Yay. You know what? The value of doing these calculations mentally is questionable. I don't know. It's just the little wins I look for in life. Now is not the time to mess up zeros. Right. 36 times 16. So that'll be 360 plus 216, which is 576 k squared. Okay, I know, look, I definitely am not doing that. 232 times 36 is 8352k. Okay, 8, man, why do I keep making the same mistake? 841 times 36 is 3276. My goodness, these numbers are bonkers. And then here we have 900 k squared minus 900, not 900, 9,000 k minus 8,100. And this gives us 324 k squared, right? So 500 and 300 is 800, 70 and 20 is 90, so we have 890, and then 6 plus 4 gives us 10. So 900 and, okay, yeah, I don't even know what I'm saying anymore. So this is also negative, right? And then we'll also have a negative 648k. And then over here we shall have 22176. Okay, right, so the long and the short is, this is the discriminant for this equation. Okay, the discriminant for this equation, I imagine, would be, if we divided, I don't know. If we divided this by 81, yeah, because what we've done here is we've times through by 9, meaning that this expression here is 9 times what it would have been, and if I square that, then it's going to be 8. So this expression is going to be 81 times what it would have been, and likewise here, this is 9 times that, this is 9 times that, so this expression is going to be 81 times what it would have been if I had used these guys, because now I've got 9 times the guy times 9 times the guy, so it's going to be 81 times what it would have been originally. And so overall, this expression is 81 times what it would have been originally. So if I wanted to find the discriminant for this guy, I could just then divide this by 81. Anyway, that's a fun fact. So what we are expecting, for example, is that when we put in k is equal to 22 over 3, this discriminant is going to be equal to 0, right? Because we know that this equation only has one solution when k is equal to 22 over 3. That's where we have the line being a tangent. So in fact, for fun, let's see that in action. It's also a good way to check whether we're on the right track or if we've possibly made a mistake somewhere along the way. Looking good already. Right, and likewise with minus 28 over 3, we should get a discriminant of 0. Oh. Hooray, hooray, hooray. Right, so now the curiosity is, for which values of k will this guy be strictly greater than 0? Right, because where it's greater than 0, then we know that the equation only it has two unequal roots. It has two distinct roots, and therefore the line y is equal to minus 4 over 3x plus k, and the circle that we have described, I don't want to say the whole equation, we will know that when k is in this range of values, then the intersection between the line and the circle, we have two of them. We have two distinct intersections as opposed to, rambling. Right, so we want to know make the discriminant greater than 0. That shouldn't have ended as a question. It's a statement. It's what we want to know. Right, so we want to solve this. I want so badly to make the number smaller again. So I'm just going to quickly on the side write down 324 is the same as 18 times 18, which is the same as 2 times 3 squared times 2 times 3 squared, which is the same as 2 squared times 3 to the 4. Of course, this can be done on a calculator. 648 is equal to 324 times 2. Oh, exciting. So that is going to be 2 to the 3 times 3 to the 4. Okay, the last one I definitely won't do by hand. 22,176. Let's figure out the prime factorization of that. Okay, 22,176. Shift fact. So that is 2 to the 5 times 3 to the 2 times 7 times 11. Okay, so the common factor for all of these guys, the highest common factor, for the 2's, the highest, the highest that they all have in common is 2 to the 2. Okay, and for the 3's, the highest that they have in common is 3 to the 2. So that's going to be 4 times 9, which is 36. Oh my goodness, of course it's 36. So from right, so it's going to come back to this. Is that true? No. Okay, no, that it's not going to come back to this because we then minus this. So I'm guessing 36 is a common factor here as well. So we could factor 36 out of the whole thing. Anyway, okay. The point is I don't know what it's going to come to. So, yeah, let's just sort of change colors because things are getting a bit bland. Okay. So I'm going to factor out a negative 36 on top of that. And over here, we will be left, okay, so the 2 to the 2 is out. And here we're just left with 3 to the 2, so I'm going to be left with a 9k squared. And then over here, 2 to the 2 is out, so we just left with a 2 and a 3 squared here as well, so that's going to be plus 18k. And then over here, we're left with an 8 times 7, 56 times 11, which is 616. Confirm. 56 times 11 is equal to 5 and a 6. You add the 5 and the 6, get a 1, and then you carry a 1 over here, and that is a 6, or 560 plus 56. Yes, okay, righty doos. Okie dokie. Right, if we then divide by negative 36 on both sides, then our sign, I don't know where this was going. That becomes that. Can I just check what time it is because I have a place to be. I didn't see the time. I'm just going to have to go faster. So I'm going to circle this so that I remember to actually change the sign. So 9k squared plus 18k minus 616 smaller than 0. Okay, so the quadratic inequality, we're going to need another page. Yo man, where's the paper manager? Where's the paper manager? The page manager. Okay, right, so let's see. This is a parabola. So this would be 9k squared plus 18k minus 616, and this is your k value. And let's just quickly see where the turning point is. Or let's just find the x-intercepts really. So I'm looking for where 9k squared plus 18k minus 616 is equal to 0. And so we use the quadratic formula. So that will be minus 18 plus or minus 18 squared minus 4 times 9 times minus 616 divided by 2 times 9. Definitely going to need space. Okay, let's do it. Do you also always start with the plus solution? I don't know, I'm just such a positive person. Okay, so as expected, k is 22 over 3, or k is negative 28 over 3, right? Because that's where we have our tangents. Okay, so right, our I just quickly guessed that it looks like this as opposed to this, because I can see that the intercept with the y-axis is going to be at negative 616, right? If I put in a 0 over here, I get a negative number, so it has to be like this as opposed to like that. Anyway, not that that really matters right now. Right, so we now know that, okay, this is negative 28 over 3, and this is 22 over 3. We are looking for the places where this expression is negative, and it is happening over here when k is between these two values. Alright, okay, so for these k values, right, so this is occurring when k is between negative 28 over 3 and 22 over 3. Right, and remember we're not including the boundaries, because when k is equal to these, then it's the expression this is equal to 0 exactly. We're looking for places where it's strictly smaller than 0. And this is the answer that we get, which is the answer that we got before. So definitely a very hairy approach, as suspected, but rewarding at the end of all the bombastic multiplications to find that, you know, even the hairy algebra root concurs with what we kind of saw visually / intuitively. Anyway, let's get back to the rest of the question. Right. Okay, so next question says point A, which has the same x and y coordinate, and B are not shown on the diagram. Okay, so point A could be 1 and 1, 2 and 2, 3 and 3, or it could be 0 and 0, negative 1 and 1, negative 2 and 2, and so on. So infinitely many possibilities for what point A can be, and point B, yeah, could be anything at this point. From point A, another tangent is drawn to touch the circle with center M, so this circle I'm guessing, at B. Okay, so B is some point on the circle, and we have drawn a tangent from A such that it touches the point B on the circle. Okay, show that the length of tangent AB is given by this expression over here. Okay, so if we were to imagine that, for example, A is somewhere over here, doesn't have to be, but just for the sake of visualizing, and B is somewhere over here, right? So this is the tangent we're talking about. Okay, except we are not drawing an infinite line, we're just drawing a line segment connecting A and B. Show that the length of this tangent is given by that expression. Okay, so there isn't really a clean way to write down the coordinates of B in terms of just one variable, because remember, our circle has the equation x, I don't remember, x minus 3 squared plus y plus 5 squared is equal to 25. X minus 3 squared plus y, oh, I've already forgotten, oh, literally have the center right there. Okay, so I mean, I guess we could make x the subject of the formula, y, we could make y the subject of the formulas so that we can write the coordinates of b as x, and whatever that expression would then become, y is equal to some expression. The tricky thing with circles is that there will always be then two, there'll be a positive square root that we have to consider and the negative square root. What I mean by that is, if we want to get the y alone, so we'll first do that. Okay, and then we'll take the square root, but it could be the positive or the negative, such as the nature of the circle. And so y would be equal to minus 5 plus or minus this. So if we wanted to write down the coordinates of b as x and the y coordinate being this, we'd have to figure out, well, is it the plus or is it the minus? We don't really know. So I am going to just not entertain that for now. Okay, anyway, so right, we know that okay, that is not what I wanted to do. I wanted the little delicate pencil. Okay, we know that that length over there would be 5. We know the radius of the circle is 5. We know that we would be able to work out an expression for that in terms of t, just using the distance formula. And then using Pythagoras, we'd be able to find an expression for that. So we'd be using the fact that this is a 90. Okay, so let's put that into symbols. So I will say, oh, do you want to rotate? Let me just lock it so that I can write however I please. iPad. So construct triangle MAB. We know that MB is perpendicular to BA because tan rad, right? Okay, we also know that MB is equal to 5 because it's a radius. Okay, and we can work out MA using the distance formula. So that will be t minus 3 squared plus t minus 5, so t plus 5 squared. Okay, I'm just going to leave that as is for now. And so therefore, this is actually where the perpendicularness comes in handy. So I'm going to move that down here actually, and then move the rest of y'all on. Oh my yeah. How life can just flash before your eyes so quickly. Right, so because they are perpendicular, I can use Pythag. So I can say AB squared is equal to MA squared minus MB squared. Okay, and that's because of Pythag. Okay, remember you can't use Pythag unless it's either been given that the triangle you're working in is right angled, or you've shown that it's right angled. Okay, so that's why it was important to state this, to say, hey, this is in fact a 90-degree angle. Okay, cool. So we then have okay, I have a feeling this is not going to fit, so let me just move it down. Oh, so sweet. I had already made space. Okay, right, so let's continue in peace. Right, so that is going to be this guy squared. So because we're square rooting and then squaring, they're going to cancel out. So that will be t minus 3 squared plus t plus 5 squared minus mb squared. So 5 squared, which is 25. Okay, so now I'm just going to then simplify so that we can hopefully get to something, well, that looks like that. Right, so that is t squared minus 3t minus 3t plus 9 plus t squared plus 5t plus 5t, so plus 10t plus 25 minus 25. Ooh, I like it. So those two will cancel out. Okay, like terms, so t squared and t squared minus 6t plus 10t, and then the constant by itself, all by myself. Don't wanna be. Okay, right, that looks good. So then AB, because we're dealing with AB is a length, so it has to just be the positive square root. We don't have to think about the negative square root in this case, which is what we were aiming for. So awesome potatoes. Right, and then the last question says determine the minimum length of AB. Okay, minimum, it's giving optimization. Yeah, trust me to be in my algebra brain in paper 2, which is definitely not wrong. So yeah, I'm definitely thinking I want to see which value of t minimizes this expression, because then the value of this whole expression, the square root of this, will be minimized. So if I can find the smallest value for this, I have found the smallest value for that. Otherwise, yeah, I don't really have an intuition for how else I would find the shortest that AB can be. So that's what I'm gonna do. Find value of t that minimizes that expression 2t squared plus 4t plus 9, right? So how it goes, this looks like, so if we look at the value of 2t squared plus 4t plus 9 versus whatever value of t we choose, that is obviously going to have a parabola relationship, right? So it's going to be a happy parabola because of that coefficient. The turning point will occur at minus 4 over 2 times 2. So minus 4 over 4, which is minus 1, right? And I'm not sure if it will, I think it's, they're all gonna be, this is an expression that's always going to yield positive values, and that makes sense because it's an expression that is being square rooted to find a distance, so it makes sense that this is always positive, right? another way we can quickly check is we can check what is the discriminant for this equation, i.e. are there any x-intercepts, and we find the discriminant is b squared minus 4 times a times c, which is 16 minus 72, which I don't really care what the value is. All I care about is the fact that it's smaller than 0. Therefore, there are no, in this case, t-intercepts. Right? Okay, so that is a smiley parabola that is completely above our t-axis. So it's going to look something like this, right? And so what we are interested in is this point over here where this expression is at its lowest, and we know that that happens when t is equal to minus 1. So we are going to find out, well, okay, when t is equal to minus 1, what is the value of this expression? So when t is equal to minus 1, then we have 2 times minus 1 squared plus 4 times minus 1 plus 9, which is 2 times 1 minus 4 plus 9. So that is 11 minus 4, which is 7. And so what that tells us is the shortest possible distance between A and B occurs when t is equal to minus 1, and that distance is 7. So just going back to our diagram, I'm going to use this one, I guess. We are saying that the shortest distance between A and B occurs when A is negative 1. I don't know where to put it. Okay, I'm just going to try to find my bearings here. So when I'm just going to try to see when x is equal to negative 1, what is the y-coordinate on the circle? What are the y-coordinates? So we know that our equation is x minus 3 squared plus y plus 5 squared is equal to 25. Okay, and I am putting in x is equal to minus 1. So that's going to be minus 4 squared, which is 16, plus y plus 5 squared is equal to 25. So y plus 5 squared is equal to 9, which means y plus 5 could be 3, or y plus 5 could be minus 3. So y, okay, so we have x. Oh, we actually know one of these. Oh my goodness. We know p is minus 1 and minus 8. Oh, this is so loud. And the other one is actually in line with the n, is minus 1 and minus 2. Right, and we have just found that when we have point A, which is minus 1 and minus 1, right, I'm not sure where it's going to be a tangent to the circle. Okay, it's going to touch the circle, definitely not at minus 1 and minus 2, so that is misleading. Can I get this any thinner? I mean, I guess technically it could also be a tangent this way. Yeah, in fact, it would work. goodness. Okay, that's a terrible tangent, but anyway, yes. So we know that this distance would be the same as this distance because two tangents meeting at one point. And yeah, that distance would be 7 units. And that would be the smallest it could possibly be. So if you were to choose a -2 and -2, for instance, and do the tangent thing, that distance would be longer. So yeah, what was the question? Determine the minimum length. We found that the minimum length is 7. What do you think, Memo? Oh, oops, it's not 7. It's not 7, it's the square root of 7. Because yes, the distance AB is actually square root of this, which we have found to be minimized at t is equal to -1, and that value is 7. So the minimum AB will be in fact the square root of 7. Cool. Chat again another time. It's never too late to change your mind.